Alright, if f of x is equal to 2 over x plus 3 and g of x is equal to 2 to the power x minus 1, find f inverse of g of x. Alright, well, first we need to find f inverse of x, right? So f inverse of x is the inverse function of f of x. So to do that, I'm going to need to let f of x equal y. So y is equal to 2 over x plus 3. Then what I want to do is isolate for x, right? Because we know that the inverse function, if the function f of x has a point x and y, the inverse function will have an equivalent point y and x, right? So you swap the x and y values. I'm going to isolate for x. So if I isolate for x, I'm going to just do the reciprocal of each. So you get x plus 3 over 2 is equal to 1 over y. And then what I want to do is, if I want to isolate for x, I'm going to multiply by 2. Whenever I do the one side, I'm going to do the other side. So you get x plus 3 is equal to 2 over y. And then I'm going to move the 3 to the other side, so x is equal to 2 over y minus 3. After you isolate for x, the third step here is change x, or swap x as f inverse of x. It becomes the y value of your inverse function, and swap y as x as the y value becomes your x value in your inverse function. So x is f inverse of x is equal to 2 over x minus 3. Okay, so this is your inverse function. And now we actually, after finding your inverse function, what you want to do is you want to find f inverse of g of x, right? So f inverse of x is composed of g. So you're doing f inverse composed of g. And in this case, g of x is 2 to the power x minus 1. So you're plugging this into your f inverse of x function. So wherever you see x, you plug in 2 to the power x minus 1. So this is going to give me 2 over 2 to the power x minus 1 minus 3. And if you wanted to simplify this a bit further, this is basically, because you're dividing the same bases, you subtract the power, so you get 1 minus x minus 1 minus 3, so it's just an exponent rule. And this is going to give you 2 to the power 1 minus x plus 1 minus 3, which is 2 to the power negative x plus 2 minus 3. Okay, so therefore f inverse of g of x is equal to 2 to the power negative x plus 2 minus 3. Okay, and that's your answer. Okay, so now that we found f inverse of g of x, we want to find the domain and range. So for looking at the domain and range here, looking at the domain, we know that this guy here is an exponential function, right? So because it's an exponential function, the domain of this function, x will belong to all real numbers. There is no restriction on x. So x belongs to a set of all real numbers. There is no restriction on x. But the range, on the other hand, will have a restriction. Now we know that our base here is positive, and that usually indicates exponential growth, right? So this is basically, if you have an exponential function b to the power x, if b is greater than 1, then you're going to see exponential growth this way. But because we have a negative associated with the x, this implies that there is a vertical reflection, right, or a reflection in the y-axis, right? We also have a shift, and if you actually factor this, you get negative x minus 2 minus 3, so you also have a shift 2 units to the right, right? So we can understand that the graph should be shifted something like this. Okay, so it should also be shifted 2 units to the right, but I'm just drawing a sketch, right? Now we also have a vertical shift 3 units down. Now in the form of an exponential function, y is equal to a bx plus c, the horizontal asymptote is y is equal to c. Okay, so in this case we also have to shift this down 3 units, right? And there should be a horizontal asymptote that occurs at y is equal to negative 3, right? So technically the graph should kind of look like this, where it's approaching the horizontal asymptote but it's not touching, right? I didn't really create a sketch, but I just showed the behavior of this graph, and we can understand here that the range of this function, y can belong to a set of all real numbers, but y has to be greater or equal to negative 3, okay? Because the horizontal asymptote it can be equal to negative 3, has to be greater than negative 3, because the horizontal asymptote occurs at y is equal to -3. Okay, so this is our range. So there is a restriction on the range for an exponential function, but the domain there is no restriction, so x belongs to a set of all real numbers.